A very good morning, children. So, we have begun to learn the lesson number 3, that is current electricity. In our previous lecture, we have learned few of the topics, that was what is electricity, potential difference, electric potential, and about free electrons. So, moving further, now we are going to learn other more concepts of this chapter. Current flowing through a wire. If a conducting wire is not connected to a cell, its free electrons move randomly in all directions in the space between the atoms. When we connect the ends of the wire to the two terminals of a cell, electric force acts on the electrons. Being negatively charged, they start moving from the negative, that is from lower potential, to the positive, that is higher potential terminal of the cell as shown in figure. Due to the flow of these electrons, current starts to flow through the wire. This motion of electrons is irregular, but there is a definite non-zero value to their average velocity. Now, electric current. An electric current is the flow of electrons through a conductor. Quantitatively, current I is defined as the charge passing through a conductor in unit time. If charge Q is flowing through cross section of a conductor in time t, then the formula, that is current I, is equals to Q upon T. The unit of charge in SI units is coulomb and is denoted by symbol C. Current is expressed in ampere A. The charge of one electron is 1.6 multiplied by 10 raised to minus 19 coulomb. So students, how is the concept of current flowing through a wire? As we know, if a conducting wire is not connected to a cell, its free electrons move randomly in all directions in the space between the atoms. When we connect the ends of the wire to the two terminals of a cell, and the two terminal is, one of the terminal is positive and another terminal we know is the negative. So, when we connect the ends of the wire to the two terminals of a cell, electric force acts on the electrons. And electrons being negatively charged, they start moving from the negative terminal, that is the terminal which has lower potential, to the positive terminal which has higher potential of the cell. So, this motions of electrons is irregular, but there is definite non-zero value of their average velocity. And due to the flow of these electrons, current starts to flow through the wire. As the electrons starts moving, current starts to flow through the wire. Now, as we all know, due to the flow of electrons, current starts flowing through the wire. Now, more about electric current. Quantitatively, current is denoted by I. The symbol for current is capital I, is defined as the charge passing through a conductor in unit time. So, current is defined as the charge passing through a conductor in a unit time. So, if charge Q, the symbol for charge is Q, charge is denoted by Q. If charge Q is flowing through cross section of a conductor in time t, then the formula derived for current is equals to I is equals to Q upon T, where I is the current, Q is the charge and T is the time. So, the unit of charge in SI unit system is coulomb and it is denoted by the symbol capital C. Current is expressed in ampere, that is capital A, and the charge of one electron is 1.6 multiplied by 10 raised to minus 19 coulomb. So the charge of one electron is 1.6 multiplied by 10 raised to minus 19 coulomb. Moving next, ampere. 1 ampere current is said to flow in a conductor if 1 coulomb charge flows through it every second. 1 ampere is equals to 1 coulomb upon 1 second. Even though electrons move from negative end to positive end, conventionally, the direction of current flow is taken to be opposite of the direction of flow of electrons, that is from the positive end to the negative end of a cell. Do you know? Very small values of current are expressed in the following units. 1 milliampere is equals to 10 raised to minus 3 ampere. Next, 1 microampere is equals to 10 raised to minus 6 ampere. And next one, ampere. Introduction to scientist. The French mathematician and scientist Ampere conducted a number of experiments on electricity. Today, we can measure the current flowing in a conductor only because of his extraordinary work. The unit of current is called ampere in recognition of his great work. Example related to current. A current of 0.4 ampere flows through a conductor for 5 minutes. How much charge would have passed through the conductor? So, given things are I is equals to 0.4 ampere and T is the time, that is time taken is given as 5 minutes, which is equals to 5 multiplied by 60 seconds. So, it gives you 300 seconds. Formula for it is Q is equals to I multiplied by T, where Q is the charge, I is the current and T is the time taken. So, we have to find out the charge. So, Q is equals to 0.4 ampere multiplied by 300 seconds. So, answer comes as 120 coulomb. We know charge is in coulomb. So, the final answer is charge passing through the conductor is equals to 120 coulomb. So, students, let's revise the numerical once again. What is the numerical given as? What's the question? A current of 0.4 ampere flows through a conductor for 5 minutes. How much charge would have passed through the conductor? So, first of all, we have to calculate the charge passed through the conductor. And what are the given things? Current is given as 0.4 ampere and the time taken for it is 5 minutes. First, we write all the given things. So, the symbol for current is I. So, I is equals to 0.4 ampere. Why ampere? Because the unit charge of current is ampere and it is denoted by capital letter A. So, I is equals to 0.4 ampere and the small t, that is time, is equals to 5 minutes. Formula is in seconds. So, we have to convert minutes into second. As we know, 1 minute carries 60 seconds. So, 5 multiplied by 60 seconds will give you 300 seconds. So, time taken is 300 seconds. Now, what's the formula? Q is equals to I multiplied by T, where Q is the charge, I is the current and T is the time. So, Q is equals to 0.4 ampere multiplied by 300 seconds. It will give you as Q is equals to 120 coulomb. What is Q? That is the charge passing through the conductor. So, final answer is how much charge would have passed through the conductor? So, the charge passing through the conductor is equals to 120 coulomb. Now moving further to the new concept, that is resistance and Ohm's law. Ohm's law. The relationship between the current flowing through a wire I and the potential difference across its ends V can be obtained from the law that was given by the German scientist George Simon Ohm. If the physical state of a conductor remains constant, the current I flowing through it is directly proportional to the potential difference V between its two ends, where current is I is directly proportional to V. I equals to kV, where K is equals to constant of proportionality. I multiplied by 1 upon K is equals to V, where 1 upon K is equals to R is equals to resistance of the conductor. I multiplied by R is equals to V. Hence, V is equals to IR, or R is equals to V upon I. This is known as Ohm's law. We can obtain the SI unit of resistance from the formula. Potential difference and current are measured in volts and amperes respectively. So, the unit of resistance is called ohm. It is indicated by the symbol ohm. 1 volt upon 1 ampere, which is equals to 1 ohm. Now, resistance and Ohm's law. Physical state of a conductor means its length, area of cross section, temperature and the material it is made up of. Resistance of 1 ohm. If 1 ampere current flows through a conductor, when 1 volt potential difference is applied between its ends, then the resistance of the conductor is 1 ohm. Next, resistance and resistivity of a conductor. As shown in figure, there are a large number of free electrons in a conductor. They are constantly in random motion. When a potential difference is applied between the two ends of the conductor, these electrons start moving from the end at lower potential to the end at higher potential. This directional motion of the electrons causes the flow of current. Moving electrons strike the atoms and ions which lie along their path. Such collisions cause hindrance to the flow of electrons and oppose the current. This hindrance is called the resistance of the conductor. An introduction to the scientist. German physicist George Simon Ohm established a law for measuring the resistance of a conductor. In his honor, the unit of resistance is called the ohm. Next, resistivity. What is resistivity? At a given temperature, the resistance R of a conductor depends on its length, that is L. Area of cross section is denoted by A and the material it is made up of. If the resistance of a conductor is R, then R is directly proportional to L. Also, R is inversely proportional to 1 upon A. Therefore, R is directly proportional to L upon A. R is equals to rho L upon A, where rho is the constant of proportionality and is called the resistivity of the material. The unit of resistivity in SI units is ohm meter. Resistivity is a specific property of a material and different materials have different resistivity. Resistivity of some materials. Copper 1.7 multiplied by 10 raised to minus 8 ohm meter. Next, nichrome 1.1 multiplied by 10 raised to minus 6 ohm meter. Next, diamond 1.62 multiplied by 10 raised to 13 to 1.62 multiplied by 10 raised to 18 ohm meter. So students, what is resistance and resistivity? Let's recall it once again. Resistance. As we all know, there are large number of free electrons in a conductor, and that electrons are constantly moving. That is, they are constantly in a random motion. So, when a potential difference is applied between the two ends of the conductor, these electrons start moving from the one end at lower potential to the end at higher potential. These directional motion of the electrons causes the flow of current. This we learnt it before. Now, these moving electrons, when the electrons move, that is when they are in motion, they strikes the atoms and ions which lie along their path, and when they strike, collisions cause hindrance to the flow of electrons and oppose the current. What is hindrance, students? In simple, hindrance means to get interfere with another. Interfering in another thing is known as hindrance. So, collisions cause hindrance to the flow of electrons and oppose the current. So, such interference, this hindrance is called the resistance of the conductor. The next concept we learned was resistivity. What is resistivity in simples? So students, resistivity is a measure of the resistance of a given size of a specific material to electrical conduction. So resistivity depends upon the resistance of that material. So resistivity is a specific property of a material, and different materials have different resistivity. Next concept, electric circuit. A continuous path of an electric current through conducting wires connected to the two ends of a cell and other resistances is called an electric circuit. A circuit is depicted by a figure. This figure shows how different components are to be connected in the circuit by using special symbols for each of the components. Such a figure is called an electric circuit diagram. In the circuit in figure, an ammeter is used to measure current and a voltmeter to measure the potential difference between the two ends of a resistor. As the voltmeter has a very high resistance, only very small current flows through it. For components of an electric circuit and their uses. Component, picture, symbol, use. Electric cell, picture, symbol, and what's the use? To apply a potential difference between two ends of a conductor. So, next, battery, collection of a number of cells. It's the picture, symbol of the battery. You can see. Next, use of battery, to apply a larger potential difference between two ends of a conductor. Next component, open tap key or plug key. Picture, symbol, use, to stop the flow of current flowing in a circuit by disconnecting two ends of a wire. Next component, close tap key or plug key. Picture, symbol, use, to start the flow of current in a circuit by connecting two ends of a wires. Next component, connecting, that is conducting wires. Picture, symbol. What's the use of conducting wire? To connect various components in the circuit. Next component, crossing wires. Picture. Symbol. What's the use? To show wires which cross but are not connected. Next component. Light bulb. Picture. Symbol. What's the use of light bulb? In an electric circuit, to test the flow of electricity, lighted, current is flowing. If it's unlighted, current is not flowing. Next component, resistance. Picture. Symbol. What's the use of resistance in electric circuit? To control the flow of current in the circuit. So resistance control the flow of current in the circuit. Next component, variable resistance. Picture. Symbol. What's the use of variable resistance? To change the resistance as required and thereby control the current. Next component, ammeter. Picture. Symbol. What's the use of an ammeter? It's to measure the current flowing in the circuit. Next component, voltmeter. Its picture. And the symbol is use of a voltmeter in an electric circuit is to measure the potential difference between 2 points in the circuit. So students, in today's lecture, we came to know about the current flowing through a wire. Next, we came to know what is electric current, ampere, and the concept of resistance and Ohm's law. The next we studied was resistance and resistivity of a conductor. Then we came to know about electric circuit. What is electric circuit? A continuous path of an electric current through conducting wires connected to the two ends of a cell and other resistances is called an electric circuit. Next, we learnt about symbols for components of an electric circuit and their uses. To get your concept more clear, watch the video repeatedly. Thank you so much, students, for your attention. Goodbye. Have a beautiful day.